Welcome, my name is Brian McLogan, and in this video, I'd like to show you how to determine the slope between 2 points. Not just by doing one example, but actually doing 12 different examples. And you can see on this worksheet that I'm going to do, we have examples that include positive, negative numbers, fractions, integers, as well as decimals. And we'll work through identifying the slope where it's positive, negative, undefined, as well as y is equal to 0. Before I get started in my examples though, I do want to cover at least an overview of slope and where the slope formula comes from. Therefore, for those of you that are kind of at the beginner stage, you're going to have a better understanding of what and why I'm doing it. If you do already know how to understand the slope and you just want to kind of see the examples, then you can kind of skip ahead of the little introduction section that I want to follow. But before even that, I would like to do a quick little shout out to my sponsor for this video, which is something new to my channel, is going to be my Starbucks mug from Germany, which I have absolutely no reason for adding a sponsor to this video. I just wanted to do it. All right, let's go ahead and get started. So for number one, we have -3, -2, and 3, -2. But to understand like the slope, right? We basically need to understand, again, what information are we given? Well, we're given coordinate points. And to understand coordinate points, we got to look at the coordinate plane. Actually, let's not do that one. Let's talk about the horizontal number line. So we start off with a horizontal number line, which we call the x value, right? And we have, tick marks going to the right, and we have tick marks going to the left. And we can call that 0, 1, 2, 3, 4. And 1, 2, 3, -4, right? And that's a horizontal number line, and we use the number lines to count, right? Well, then we say, well, if we add a second dimension here and we throw a vertical number line, we're going to call that the y number line. So all a coordinate point is 1, 2, 3, 4, and 1, 2, 3, 4, is just a point on this what we call the coordinate plane, where not only do we have a horizontal direction, but we also have a vertical direction, right? And we label those coordinate points as like a x, y. So I'm just going to kind of put a point here. Here we have x, comma, y. So x represents the horizontal distance away from like the origin here, 0, and y represents that vertical distance, right? And notice when x is positive, when x is negative, when y is positive, when y is negative. Now, you can see, though, we don't have just one coordinate point, right? We have here one xy, and then we have another xy. So let's just, again, I'm not graphing these points, although I probably should. But let's just go ahead and find, let's say there's another xy point. Now, the important thing is we need some way to differentiate between those 2 points, all right? So in the slope formula, we could use different letters, but a lot of times we want them to understand that they're both x's and they're both y's. They're just different x's and y's. And so what we can say is, this can be our first x, and that be our first y. And that can be our second x and our second y, which is also known as like our x2, comma, y2. Now, when we're identifying the slope, basically what we're asking ourselves is, what is the change as we go from x1, y1 to x2, y2? Like, what are we doing? Now, on the basis here, you could say, well, you're just going up, right? As you read this from x1, y1 to x2, y2, you say you're, rising. Well, how fast are you rising? Because we recognize that we can rise really fast, we can rise really slow, and we could rise like not at all, right? Or that was supposed to be a half line. Okay? And in addition to that, if we kept on actually slowing down our rise, we could actually be falling down, right? Or we could falling down really, really fast. So the change as we read this from left to right, that is basically exactly what slope is. It's the change in, it's our change in kind of our elevation from the y's and the x. And there's a lot of different ways that we, can represent this. But basically on a phase is that change in your height over the change in your distance, in your length. Okay, and the best way I think to visualize that is by using a triangle. So let's say this is 5 and 6. And let's say this is 1, that's 2, and that's 4. All right, so basically what we're looking for, actually I don't want to put any points in there, but if we want to find the change in our height, we want to say, all right, we're at this height, and now we went, and we started here, and then we went up to here. So if we do y2 minus y1, that's going to be the change in our height. Or if we want to find the change in how far we traveled, so we went from y1 or x1 to x2. Therefore, to find the change there, we do x2 minus x1. So the slope is this ratio. It's the ratio of the change in the height over the change in your distance or your horizontal distance. Also a lot of times known as your run. So we can look at the slope here. You know, a lot of people remember it as rise over run. Basically, how far did you go up compared to how far did you go over? And mathematically, a lot of times we use, when we're talking about x1 and y1 and x2 and y2, we use this formula. M equals y2 minus y1 over x2 minus x1. So that's at least going to be the understanding of why we're doing what we're doing. We're trying to find this change vertically divided by the change horizontally. And that's going to tell us a slope. That's going to tell us how fast something is, rising or falling from one point to the next. And that helps us. If we know something has a positive slope of very fast growth, we know that it's going to be very quickly going up to that next point. Whereas something has a slow growth or a low slope, then we know that it's very slowly, gradually going up. So I think that'll make a little bit more sense once we kind of, look at what the graphs kind of show here. So for the first, let's do these first three. Let's go ahead and, actually first four, let's go ahead and graph these to kind of get a better understanding. So I'm going to graph these on the Cartesian coordinate plane. So -3, -2. And then we have +3, -2. Okay, so you can see as I move from like x1, y1 to x2, y2, my points do not go up at all. So therefore, the change in the height is going to be 0. Therefore, the slope is going to be 0. But to make sure we just kind of confirm this, let's go ahead and put them into the slope formula. -2 minus -2. Notice how I put that second -2 in the formula. It's y2 minus y1. So y2 minus y1. And y1 is -2. Then we have x2 minus -3. Well, when you go ahead and simplify this, -2 minus a negative is positive. So that's a 0 over 6, which is just equal to 0, which confirms what we already knew from the graphical approach. But obviously, guys, the idea here is not to always have to graph them, because sometimes we're going to get problems, for instance, at the end, where we're not going to want to graph that. All right. So therefore, we'll want to make sure we understand at least this change here. All right, let's go ahead and look at the next one. Let's go ahead and graph it to get a visual understanding. So we have 5, -1, 1, 2, 3, 4, 5. And we have 8, -4, 5, 6, 7, 8, -4, 1, 2, 3, 4. Okay, so I'm just calling the point to the left x1, y1. You could really actually label them any way you want to. It doesn't really matter. But as you kind of as we go from this one, as we're reading this from x1, y1 to x2, y2, you can see that we're falling, right? We're going down. So therefore, our slope is going to be negative. So we recognize something as a positive slope as far as going up from left to right and down from left to right as the slope is being negative. So let's make sure when we do our slope, that's going to make sense. So we have y2, which is -4. Minus a y1, again, using parentheses here, and that's 8 minus 5. Now, you could use parentheses for the 5, but again, since it's positive, it doesn't really matter. So therefore, I have a -4 minus a -1, which is going to give me a -3, over 8 minus 5, which is +3, which gives me a slope that can be just rewritten as an integer. So this is your change in your height over your change in your run, which makes sense, right? To go from here to here, if you look at this as a triangle, I went down 3, and over 3. And you can confirm that just by looking at my graph. Now, again, we're not always going to want to sketch the graph, but at least you guys can see my change in my height compared to my change in my horizontal distance. And it makes sense for my answer. However, we can just simplify this as a -1. We don't need to write a fraction like that. A lot of times we'll just simplify that. If it can be simplified, then we'll simplify it just as an integer. All right, now let's just go ahead and get into some fraction operations. And just remember, when we're doing fractions, we got to make sure we have common denominators. All right. Some people might be familiar with this. These, as far as decimal version, 2 goes into 3 one time with a remainder of 1. So therefore, we can rewrite that as 1.5. So therefore, it'd be 1.5 or 1.5. 2 goes into 7 3 times with a remainder. So that would be 0, 3.5. Or 3.5. I don't know why I put a third there. So I'm just going to do that because that's going to, I told you I would graph them. So I kind of stuck to my word, graphing fractions. So we have -1. So we have -1 and 1.5 between 1 and 2. And then we have 0, 3.5. 1, 2, 3, and between there. So if we're reading this as x1, y1, and this being x2, y2, then you can see that the slope here is going to be positive. As we read this from left to right, you can see that we are going up. So therefore, let's just go ahead and confirm that is going to be the case. Now, I'm not going to write these as the mixed numbers. The only reason why I wrote these as the mixed numbers, just so you could see, you know, what the mixed number would be or the decimal equivalent. So therefore, it's a little bit easier to graph. Some people don't like graphing improper fractions, so they want to convert them to mixed numbers or a decimal equivalent. That's perfectly fine. When I'm applying operations, though, I am perfectly fine with, I prefer just to use the improper fractions, because as long as they have the same denominator, that's a -1. As long as I have the same denominator, I just subtract the numerator. So in this case, I have 7 halves minus 3 halves, which is going to be 4 halves, divided by a minus a -1, which is a +1. Well, 4 divided by 2, I'm sorry, is 2. Divided by 1 is just going to give me 2. And that makes sense, right? This graph goes up 2, forever over 1, right? And you can visualize that. You can see how that works. All right, last one. Let's go ahead and get this one graphed. So we have +2, -4, 1, 2, 3, 4. And then we have +4, 1, 2, 3, 4, -1. Okay, so again, we can see as we move from left to right, this graph is going to be going up. So therefore, we should have a positive slope. So m is going to be y2 minus y1. Again, the major mistake people make is not using their parentheses. 4 minus 2, and they make the mistake with those positive negatives. So minus negative is like adding, so therefore that's 3 over 4 minus 2 is 2. So therefore, this slope is 3 halves, which cannot be simplified. And again, let's just verify this. 1, 2, 3 over 2. Up 3 over 2, which is called that slope triangle. And you guys can see that that makes sense. The change in the height over the change in the horizontal distance. Okay, so now I gave you guys at least that visual that you guys can use with the triangle so you can visually understand, make sure these formulas, this change in height over change in distance makes sense, or the change in rise over the change in run. Now we're just going to rely exactly on this x2, y points. So we're just going to rely just on the formula to go ahead and solve this. And actually, let's kind of use some tricks. Let's use a couple tricks here for these next two. Or for this next one. This next one, I noticed that my x1 and my x2 are exactly the same, right? Now, you got to be careful because sometimes they'll be exactly the same, but one's positive and one's negative. So when you're finding the difference of a positive and a negative number, that's not going to be 0, right? You got to think, well, first of all, that's an x coordinate, that's a y coordinate. So you're never even going to be subtracting these at all. But you can see here, when the -2's were exactly the same and I subtracted them, I got to 0. Right? Because they were both -2 and they were both y coordinates. Here, my x coordinates are exactly the same and they're exactly the same sign. So therefore, I know it's going to give me 0. Now, let's just go ahead and do it. So m equals 2 minus 5 over 7 halves minus 7 halves. So I didn't even have to do the formula to recognize that I'm going to have 0 in my denominator. And we can't divide by 0. And so therefore, that's not going to give us any slope. So therefore, that is going to be an undefined slope. Now, if you wanted to understand where is this graph, like what does that represent? That's going to represent a vertical line. There is a distance here, right? So 1, 2, 3, 4. 3 halves 2. And then 3, 4, 5. So what you can see is they have a vertical change, but there's no horizontal distance. So the slope is what we say considered undefined. There is nothing positive nor negative slope because you can't move left to right from one point to the next. You're going directly vertical. So the slope is undefined. Now you have to be careful though of doing tricks like this and saying, oh, they're the same. That's going to be a slope 0 because you have to understand if the slope is 0 in the numerator, it's going to be a horizontal slope, not going up or down. But if the values are the same in the x-coordinate, then you can recognize that, oh, okay, that's going to make an undefined slope. A lot of students will try to make those tricks, and they'll see a problem like this, and they'll say, oh, that's going to be undefined, or it's going to be 0. But as you look at this, that's a -1, that's a 1. That's a -4, and that's a +4. When you actually do the math here, that doesn't work for y2 minus y1. over y2 minus y1. And again, when I'm subtracting a negative, I use those parentheses. So you owe me $4, you borrow $4 more, you now owe me $8. Minus a negative is like the positive, so like you owe me $1, so 1 plus 1 is going to be 2, which gives me a negative 4. And you can always rewrite that as over 1, but you can see that the graph, that graph is actually going to be a negative slope. All right, so now we have a problem that does not seem too fun. It has fractions without common denominators. So the first thing you'd recognize, though, if I'm subtracting my y coordinates and my x coordinates, though, they both actually do have common denominators. So this one's actually not as bad as I was initially thinking. So again, I'm always treating the second point here as my y2, y1, and here's my x1, y1. So x2, y2, x1, y1. So I have 1/3 minus 2/3. And here I have 5/4 minus 3/4. Okay, since the denominators are the same, I get a negative 1/3 divided by, let's see, that is going to be 5/4 minus 3/4. That's going to be a 2/4. Now I can just reduce that to a 1/2. So let's go ahead and, so this is negative 1/3. Now I could reduce it down to a 1/2, but for the sake of my work here, remember when you're dividing by a fraction, if I want to get this to be 1, I want to get rid of a fraction divided by a fraction, I can get rid of this by multiplying by the reciprocal. So I'm going to reduce the reciprocal, and 2/4 is the same thing as 1/2. But if you multiply by the reciprocal of 2/1, right? So like 2/4 is the 1/2. If you multiply by the reciprocal, that's going to eliminate your denominator. Because watch, 2 times 2 is 4. Divided by 4 times 1 is 1. So therefore, what we obtain, I just wrote the equal sign again, is a negative 2/3. So that's going to be a negative 2/3. And you can write the negative in the numerator or in the denominator. It does not matter, which is one thing I'll get through on examples 9, 10, and 11 for you guys to visualize. The next one does not seem fun at all, so let's go right into it. So I have the change in y over the change in x. So I'll name this x1, y1, and x2, y2. So in this case, nothing is the same, so I'm just going to have to do this one. So I have 2/3 minus 3/8 divided by a negative 1/2 minus 5/7. All right, so the tough thing about this is you cannot subtract your fractions unless they have the same denominator. So therefore, I need to find the common denominator of 3 and 8, which is just going to be the product of 3 and 8, which would be 24. So to get 24 as my common denominator, I need to multiply by 8 on the top and the bottom, and 3 on the top and the bottom on the right-hand side. Now, don't make the mistake of only multiplying on the top or only on the bottom, because that's not going to produce what we call an equivalent fraction. So you got to make sure you multiply on the top and the bottom of your number. And again, you'll notice when I do this, when I multiply by these numbers, 8 times 3 is 24, 8 times 3 is 24. So I'm going to get my common denominators that I can now apply my operations to my numerator. In the same respect here, we need to find the common denominator of 2 and 7. Well, they don't have any common multiples in between them. So therefore, we're just going to multiply them to get a common multiple of 14. So I obtain a common multiple of 14 in the denominators, which would be your common denominator. I'm going to need to multiply by a 7 over a 7 and a 2 over 2. Now, this negative, where does it go? You can leave it in front, or typically it's just probably easiest to leave this in the front, or I'm sorry, in the numerator. So let's go ahead and rewrite everything. So I have 8 times 2, which is 16 over 24, minus 9 over 24. Divided by 7 times negative 1 is a negative 7 divided by 24. I'm sorry, that's 14, right? 2 times 7 is 14. And 5 times 2 is 10, so that's minus 10 over 14. All right, so now you can see I obtained common denominators, so now I'm just going to apply the operations. 16 minus 9 is going to be 7 over 24. And negative 7 minus 10 is a negative 17 over 14. And again, if you have a fraction, our idea, guys, we don't want to divide by fraction. We want to get rid of this. Look how many fraction bars I have. 1, 2, 3. So let's get rid of this fraction. So I can't subtract to get rid of the fraction. To get rid of the fraction, I need to multiply by the reciprocal. Because if you multiply by the reciprocal right here, you are going to, if you multiply by this reciprocal, they're going to make that denominator equal to 1. And as long as you multiply the denominator and the numerator by the same number, you're not changing the value of the fraction. So let's multiply by a 14 over negative 17. It doesn't matter what's in the numerator, what's in the denominator. Okay, can anything be divided out? So now that goes ahead and gets divided out, right? You can see that's going to go to 1. Here, these are both divisible by 2. So rather than dividing that out, I'm going to rewrite this as 7 times 7. And this would be 12 times negative 17. Now, I do not know, or at least I do not recall 12 times 17, so I'm actually going to cheat over here and just use my computer calculator just to make sure that I have this 204. So therefore I have 49, or negative, put the negative in front, 49 over 204. Okay, now let's kind of bring up something that I didn't really talk about is, what about if I have points, like what if I want this to be x2 and this to be x, actually no, let's not do it for that one. Let's do it for the next example. So this one's x1, let's make that one y1, x2, y2. And so therefore let's do the slope here. So this is a negative 15 minus a negative 2. And this one's a negative 11 minus a negative 5. So again, notice how I'm keeping those signs of the negative 15 and the negative 2 when I'm subtracting them. All right, so minus a negative, that turns it to a positive. So that's going to be a negative 13. And that turns it to a positive over a negative 6. Now I have a negative divided by another negative. So therefore, that's going to turn to a positive. All right. So just be very careful with the signs. That gets a lot of students. Now let's go and take a look. What if I had a little fun here? Let's go ahead and graph these. So 2, 1, and 1, 5. 1, 1, 2, 3, 4, 5. Okay, so as we read this left to right, we know that the slope is going to be negative, right? But what if we, instead of calling this x1, y1 and this x2, y2, like I've done for every single example, why don't we switch it around? Why don't I put, because hopefully you've kind of asked yourself that question if you don't know the answer to it, why not put this one as x2, y2? Why not make the second one x1, y1? I don't know why I keep on doing double x's. So let's go and see what happens when I switch them around, when I make this the second point and this the first point. Now, before we do that though, we got to kind of like understand what we're doing. Instead of, if we had 2, 1 is right here, and here's 1, 5. So if we're reading from this point, so typically we read from, this point to that point. What we're doing is we're actually going left. So you can see and that's sometimes the case, like the first problem I did, it kind of made sense to read from left to right, right? This point left and that one was right. So the first point was more left than the second point, but that's not always the case. 2, 1 is more to the right than to the left. So even though we're going up, we're going to the left. And so we're not reading from left to right, we're reading in the opposite direction, which is going to be the negative direction, right? As you move on the number line going to the left, for you guys that way, it's becoming more negative. So my slope should be negative. So let's go ahead and take a look at this. And we already know that from the graph. Even if we read this from left to right, we see that it's a negative slope, right? But if we read this from right to left, we're going up, but we're reading it in the negative direction. All right, so let's go and do this. So I'll have y2, which would be 1 minus 5, divided by x2, which is 2 minus 1. And therefore, we have this negative 4 over 1. Now, this gets a lot of students confused. They say, oh, negative 4, that means down, right? Your rise is down. Yes, but remember, the negative can be put anywhere. It can be put in below, or it can just be put in front. So let's go ahead and check, because technically even the slope is also just a negative 4. But let's use this change in height over change in width. So down 4 over 1 is going to represent it reading from left to right. But what if I read it as 4 negative 1? That would be a rise in 4, but a left direction, a left horizontal direction to the left. So either way, guys, if you know, whatever point you pick, the point that I'm trying to make is it doesn't matter which point you represent as x1, y1. Typically, we read points from left to right, but either way, your math is always going to produce a negative slope. So it's either going to be a negative direction down, a positive direction right, or it's going to be a positive direction up and a negative direction, horizontal. Obviously, when it's positive, that works the exact same way. So you can go up and to the right, which would be positive and positive, or you could go down and to the left, which would be negative and negative, which would still produce a positive slope. Let's go ahead and do this one to prove that. So in this point, I have 0, 2, and I have 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. So hopefully you recognize here, if I was to read this from left to right, if I was going to make this my x1, y1, and this my x2, y2, you can see that I have a positive slope, right? Boom, boom, boom. Well, what if I want to do it the other way? What if I make this y1 and this x1? And this x2 and this y2. So as I do the slope format, I have y1 minus y2. I'm sorry, y2 minus y1, right? Follow the formula. Y2. Okay, so I'd have 2 minus 5 divided by x2, which would be 0 minus 3. Now when I get my slope, I get a negative 3 over a negative 3. Now this can be reduced to a positive 1, but it's really important for you to just look at this negative 3 over negative 3. Again, when we read this from left to right, we're reading it, up and over. But if we're reading it from this is the first point, 3, 5, and this is the second point we're going to read, this is reading down 3, negative 3. And again, as you read from left to right, that's correct. Down 3 to the right 3. So it really all depends on your perspective on how you're reading the slope. And typically, it doesn't matter. Either one of those, 3 over 3 or negative 3 or negative 3, they both give you the slope of the answer, which is 1. So it's really not going to make a difference here in that regard. So that's why it's kind of important in this case. Or at least for you to understand when you can have positive negative slopes and the order doesn't matter. Just make sure that if you look at this or you get kind of confused, look at the graph so you can identify how that slope pattern is. All right, guys, last but not least here is one with decimals, and I'm not really sure why I initially did one with decimals. But we'll go ahead and do it here. So I'm just going to use a calculator just because I don't want to make a silly minor mistake doing some mental arithmetic. Now this one again, even though now we know that order does not matter, let's just go ahead and label these, and then let's just plug them in. So we have 5.8 minus a negative 2.25, which is basically adding. So 2.25. And then we have a 7.25 minus a 3.6. Okay, so I'm just going to go ahead and, I noticed that the minus the negative is really like adding, so it's going to be 5.8. And then add 2.25. And that gives me 8.05. And then divided, just use my calculator, 7.25 minus 3.6. 3.65. All right, if you did not have a calculator, what could you do? Well, my advice would just be to multiply everything by 10. And if you multiply everything by 10, or even actually since you have this double dash, you multiply everything by 100. If you multiply everything by 100, then you can just work with integers. And the ratio of the slope is going to be the same if they're in multiples of 10, hundreds, or anything else. Because again, the slope is a ratio. It's a comparison of how high it is between 2 points as well as how far over it is. So the slope is not going to change if you use a magnitude of, if you multiply this by 100. So if you multiply this by 100, then basically you're moving the decimal point over 2 points. So you have negative 225, comma 360. And comma, there we go. And therefore, then over here, you'd have 725 and 580. 225. That. So therefore, when you go ahead and solve these, or you go ahead and do 580, plus 225, what you're going to get is 700 or 805. So actually, let's write in that slope here. So when you do y2 minus y1, you're basically doing, so m equals 580 minus 225 all over 725. No, crap. Did I change these up? I did mess it up. It's y2 minus y1. Oh man, thankfully I checked my work. Jeez. Oh, well, that's all correct, but not that. All right, last video or last problem, making some mistakes. So this is 5.8 minus 3.6 all over 7.25 minus a negative 2.25. Okay, if we put that now in terms of hundreds, let's say we have 580, right? Multiply it by 100 minus 360. Then that's going to be divided by my x coordinates, which would be 725 minus a negative 225. All right, so I just want you guys to see, how these are going to work out. That's going to be 220. All over, this is going to be positive. That's going to be 950. All right, and I just want you guys to see, if I was to use the decimals, because I had a calculator, 5.8 minus 3.6, I get 2.2, which obviously I should know. And then if I have this, it's going to be 7.25 plus minus a negative 2.25, which should be 9.5, which is correct. Okay. Now, ladies and gentlemen, if we're going to take these two values, it doesn't matter which one, 2.2 divided by 9.5. Just if you want to see like the actual decimal here, this is all going to approximate to 2.3. I'm sorry. This ratio as like a slope is a decimal of 0.23. So if we wanted to actually write this slope as like one little decimal, you could say it's approximately going to be 0.23. It continues going on, and that doesn't matter if you do 220 divided by 950 or if you're using that. So there's at least a way you guys can go about it without using a calculator. But the main thing is really understanding how to use this slope formula, and really how to understand slope, this change in the height compared to the change in the distance between 2 points, the change in the rise over the change in the run, this comparison, right? The comparison of this change in the height compared to the change in the distance. So that is the slope. That is the slope formula. And hopefully you enjoyed this lesson, and I look forward to being able to teach you on the next one. Cheers.